Guys, we're going to go through 3.11 specialist techniques and processes. The thing I find annoying with this specification is that there's a lot of stuff already covered. Topic 3 is kind of just a mishmash of things that have already been covered in topics 1 and 2 and your NEA. So it's kind of just pulling all that together. So that's why, I mean, this sounds like it's from topic 2. So let's just get into it. So the first one we're going to talk about is timbers. Now, we're talking here about specialist techniques and processes. So in relation to timbers, we can then have a look at these and think, right, well, yeah, what is specialist about the process that would be used? Sometimes when we're looking at products, you as a designer might look at it and wonder how it was made. At least I hope you do, if you're, design minded. So you might even look at a highly ornate decorative piece of carpentry like this and think, well, how on earth was that made? So the answer is for things like this, traditional craft, it's commonly things like saws, mitre gauges. I mean, mitre gauges are quite sort of basic little things actually. You might remember it from in year 10, but it's sort of like a stick with a sliding thing on it, and it's got this screw that goes in so you can tighten it, and it has like these little spikes that come out. And what they can do is the spikes can actually help you mark down on a line of wood. So if you're trying to mark a straight line along a piece of timber, you can actually get it so the little mark you make slides perfectly along, parallel to the edge of the timber, like along the edge there. So that's kind of what a mitre gauge is for. Chisels are great for really detailed carvings, like all these tiny little bits here. That's what sort of master carpenters would have used, would have been chisels, and then sanding obviously to finish. So those are the typical sort of more what I call like traditional tools or handcrafting or something like that. That's kind of typically what you'd expect to see. And when we say saws as well, I mean, excuse me, there are a few different saws that we can talk about if you want to show off. We have a tenon saw, which is the one that is for straight cuts. You have the coping saw, which is good for very sort of curvy detail cuts. You've got a panel saw, which is basically a tenon saw just without the sort of solid top to it. So panel saw is good for cutting like through whole planks and things like that. And then obviously you get the power saws, like you get the circular saw and you get the band saw. Yeah, there's lots of different types depending on what you're trying to do. Um, for things like straight cuts, if you're trying to do a perfectly straight cut, you want a circular saw because the diameter of the blade means that once it plows through the material, if the material that you're cutting through is only like, say, that big, you'll get a perfectly straight cut as it goes down through the material there. Whereas if you try cutting a straight line with a coping saw is very difficult. So the next techniques to look at are laminating. Laminating is typically where we use thin sheets of veneer. Now this is basically what plywood is with glue. It's like making a sandwich, or if you've ever eaten a lasagna, a lasagna is made up of you've got your sort of sheets of pasta, and then in between that you've got all the nice stuff. You've got like all the let's do that in a thicker line. You've got all like the sauce and the meat and all that kind of thing, all the yummy bits in between. That's really what plywood is like, and then plywood bends into laminating. So all they do in this instance is they do that same sandwich construction there, but they just do it around a mold. So if we got like glue, and then the black is veneer, if you then wrap that around a shape whilst the glue's wet, you then get you can then get a really nice sort of very complex shapes actually. So you can have a situation like this. You can have a former like that, and then you literally are just bending the material around. Let's find a let's use that. That's the wood, and then it's just alternating. So alternating over glue and wood, and then the only thing you need to do is to then clamp it in many points all the way around whilst the glue sets. And then once the glue is set, you're then good to go. You can unclamp it and then the wood will stay in that position. So that's to get really curvy shapes. Then for things that are sort of more, well, these kind of look like two-dimensional panels that have just been stuck together or slotted together or bolted together or something. So when we see things like this, where you've got straight through cuts through a design, we should immediately start thinking, ah, right, well, that looks like it's been laser cut or it's been CNC'd or something like that, because the CNC machine can cut out these pockets very quickly, compared to how you might do it by hand, and also very accurately as well. It can cut out all those parts really, really accurately and very quickly, and also you can minimize wastage. So if I'm going to draw, imagine this is a massive sheet of plywood that we've got that's gone into our CNC machine. Now, what's really good is that inside that sheet of material, like we've got a part there, we've got a part there, we've got like the seat, we've got the back. We could probably then fit most of those parts into one piece of plywood. So if that's the one bit, one of the bits of the back, oh sorry, the legs, and then maybe that's like the back pieces there, and then you'd probably be able to fit on the remaining pieces, something like that. And then you've got minimal wastage. So we call that nesting, and that's what's really good with laser cutting and CNC. All right, let's move on to plastics. Plastics in the workshop in school, they kind of broken down into either 2D, like laser cutting, or 3D, which is 3D printing and things like vacuum forming or thermoforming. 2D is, well, or you could call it 2.5D maybe, because basically what this does is it's taking a shape and then it's just cutting a straight line through the material. It's not like it can make, say, that curvature of the boat. A laser cutter can't do that. So if it was cutting a boat, it would literally just be a straight-sided shape going down through the material like that, and then you'd have to shape it by hand afterwards. So that's the difference between laser cutting and then the 3D processes. Laser cutting is very quick and it's very accurate. 3D printing is slow, but it's accurate. And also 3D printing, you can actually print complex assemblies all in one go. So you can see all these parts here have been 3D printed. So we've got like the engine there, the jet engine at the back, and then the frame, and all those kinds of things can all be printed actually at the same time. So you can actually print an assembly. Vacuum forming is good, but it is only as good as the wooden mold that you have that goes underneath the plastic when it's being formed, because it uses a hot sheet of high impact polystyrene, and then a vacuum will then suck the plastic around that mold, and then it will take on the form of the mold. So if your mold is really, really good and really accurate and very smooth and of a high quality, the molding you have will reflect that. But if your former is really rough and just generally a bit mucky and not very nice, then your molding will come out looking the same as well. Let's move on to metals. Hopefully, a lot of this will be familiar to you. In industry, you can laser cut metals. They have fiber optic lasers that are a lot more powerful, that can just smash through the metal. The downside with this are that laser cutters leave burn marks or heat marks, because obviously it uses heat. So an alternative that you can use is our good friend, the water jet cutter. So water jetting is a cold process because it uses water, so you don't get the same burn marks. So that's really good, obviously, for detailed cuts. If you've just got a sheet of mild steel or something like this, you just want to cut the strip out, you can use tin snips. Tin snips, they're not very accurate and the finish is not good. You have to file it down, but it's fairly quick. But you're very much limited to, I'd say, it can't be any greater than like 1.5 millimeter thick steel that you cut, because it's just too difficult. And then the other way is, melting the metal and pouring it into a mold, like a lot of you will have done with pewter casting, as shown here. And that's really nice because obviously you can laser cut the mold here, so you can get that accuracy. And then the metal, because liquid metal is so fluid, it will take on any form of mold you pour it into. The last one here is CNC milling. Now this is great. Just like CNC routing for the woods here, CNC milling is great because it is oh, I'm terribly sorry, I went too far. CNC milling is a 3D process, so you can get so much complexity into a block of aluminium. This is how Apple make their MacBook Pros. If that was or all their products are actually made with CNC. If that was just a solid block of aluminium that goes in, the CNC cutter head would just come down and it will just move along all those paths up and down until eventually it's wasted away all the area that needs to be removed. It's amazing because you can just press go and let it do its thing, and the finish can be unbelievable, but it can be slow. But then again, slow relative to the quality, that's something you can think about because to make that by hand to the same quality would be, I mean, months of work, at least. So CNC will do it in a few hours. So, yeah. Okay, then the last bit is finishes. So, finishes are broken down into two sections. You can either have protective or aesthetic. Aesthetic meaning a finish is applied just to make it look nice, and protective is meaning that it stops the material from corroding or degrading, or whatever. Now, woods, these are very susceptible to rot and bacteria and damp, lice, fungal growth if they are not treated properly. So often, once the wood has been formed, you need to then get some waxes, varnishes, lacquers, stains, preservatives, even, or just regular paint. Like whenever you write paint in the exam, just put acrylic paint. That's the safe standard. Yeah, and that's a great way to protect it. Then it won't bend, warp, go rotten, whatever. And the end grain, which is this bit here, because the fibers of the wood run lengthways, as you can see with the grain, this is like a sponge, this end. So what happens is when you put on with a brush, say, if you put on a lovely layer of varnish along the edge of the timber there, what will happen is that varnish you put on the end, it'll all be sucked up into the length of the timber from the end grain there. So that's quite a good way of doing it. Metals, in terms of coating them to protect them, you can. The reason we do this is because mild steel, for example, is a very cheap metal. That's the steel that most of the classroom furniture in school is made from mild steel, and then they coat it either in paint or they dip coat it, like is going on here. This is called hot dip coating. So that's getting molten zinc, and then they just dip it in, and then it comes out protected by zinc. It's so much cheaper than making the whole thing from zinc because you're just using a cheap base metal, mild steel, and then you coat it in a fancy metal. So another word for that is also electroplating is slightly different, but um, galvanizing and dip coating are basically what this is. It's just hot dip coating, dipping into molten metal. And then electroplating and anodizing is where you're using an electric charge to make particles cling on to a charged piece of metal that you have in a solution. So, for example, you might have a bath of copper sulfate and you have your cheap base metal part of steel. You would have that connected to the cathode and dunked into the copper sulfate. And then you'd have an anode, which is just a big piece of copper connected to obviously the positive charge. And what will happen is the copper particles will then be attracted to the steel and it will coat it. And then you get a lovely, I guess, a non-ferrous coating, which is very nice. Then the last one, plastics. There's not much you can do with plastics, really. The only thing you can really do is print on them as a post-process. So here, this is called screen printing. Screen printing is kind of how graphics is applied to products. I mean, we're talking any material like woods, metals, plastics, but it's often used on plastics. So it's just getting ink. They have a screen or stencil which has the gaps left, and then this squishy arm just sweeps the ink through, and it pushes it onto the surface. Yeah, and that's about it. So when you've been through that and made your notes, you then have a go at the practice questions, and I will then go through them.